Look up at the night sky. What you see is more than stars, it's a chaotic dance of fire and gravity. Today, we embark on an extraordinary journey through our solar system, a place of unimaginable power. We begin with the sun, a roaring beast of pure energy that dictates the rhythm of life. Close by, Mercury lies stripped to its metallic bones, while Venus remains a scorching hellscape, a cautionary tale of a world that lost its way. Then, there's us, Earth, a fragile blue marble, an anomaly of balance where everything conspires to sustain the flame of life. Beyond the red sands of Mars, we enter the realm of the giants. Jupiter, the undisputed king, stands as a massive sentinel, while Saturn wears its icy rings like a crown. As we drift toward the darkness, Uranus spins in defiance, and finally, Neptune, a ghost world discovered by the relentless force of human mathematics. We are but a tiny speck in this vast machinery, but we are the speck that looks up, wonders, and calculates. This journey is brought to you by Inertia on the Voyage. If you enjoyed this cosmic voyage, please subscribe and hit that like button. Thank you for watching. Enjoying the view? Don't forget to hit like and subscribe for more content. High above us shines the absolute ruler of our solar system, the Sun. It is a titan of physics, pulsing with dynamic energy that dwarfs our comprehension. It holds 99.86% of the solar system's entire mass. If you were to gather every planet, moon, asteroid, and comet, they would amount to a mere 0.14%. This invisible tether of gravity dictates the orbital architecture of every object, from the rocky shores of Mercury to the frozen depths of the Oort cloud. We are, quite literally, held in place by its relentless grip. Look closely at this gargantuan star, and you will find an object of impossible precision. With a diameter of 1.39 million kilometers, enough to line up 109 Earths side by side, it remains one of the most perfect spheres in nature. Despite its size, the difference between its equatorial and polar diameters is a mere 10 kilometers. It is a swirling, convective ocean of ionized gas and plasma. Unlike a solid planet, the Sun rotates at different speeds at its equator and its poles, a phenomenon called differential rotation. This shearing motion is the heartbeat of the Sun, twisting magnetic field lines into knots and driving the solar dynamo. It is a star that is essentially alive with motion. But do you know the Sun's true color? We often paint it yellow or orange, but from the vacuum of space, the Sun is pure, brilliant white. It emits light across the entire electromagnetic spectrum. Our atmosphere simply scatters the shorter, blue wavelengths, leaving us with a yellow tint. The same logic explains our sunset. As light travels through miles of thick atmosphere, only the stubborn, long wavelength red photons reach our eyes. If you were standing on the moon, you would see the Sun for what it truly is, an intense, stark, blinding white spotlight against the velvet black of the cosmos. Historically, our understanding of the Sun has been a journey of trial and error. Galileo was one of the first to track sunspots, realizing the Sun was not a perfect, immutable orb, but a dynamic, changing body. For centuries, humanity observed the Sun only through visible light, until the 20th century, when radio astronomy and space-based satellites peeled back the veil. We discovered the corona, an outer atmosphere millions of degrees hotter than the surface, a solar mystery that continues to puzzle physicists to this day. Deep within its heart, the core, the Sun burns at 15 million Kelvin, under pressures 150 times denser than water. Here, 600 million tons of hydrogen are fused into helium every single second. This process releases energy following Einstein's iconic equation, E equals mc squared. But that energy is not free yet, it must undergo a chaotic journey. A photon born in the core zigzags through the dense interior for up to 170,000 years. Interestingly, the core also produces billions of subatomic particles called neutrinos. These ghostly particles stream out of the Sun at nearly the speed of light, passing through the Earth, and through us, by the trillions every second. providing us with a real-time snapshot of the fusion reactions happening deep inside the core right now. Between the radiative zone and the surface lies the tachocline, the engine room. Here, the transition between layers generates the most powerful magnetic fields in our system. These magnetic lines get twisted and tangled, eventually snapping like overstretched rubber bands. When they break, they release the spectacular eruptions we call solar flares and coronal mass ejections. We are currently in the midst of solar cycle 25, having officially peaked in the solar maximum in October 2024. The sun's intensity has not waned in 2026. Frequent X-class flares have continued to challenge our global communication and power grids as the sun's magnetic poles prepare to flip. This cycle is a stark reminder that we live within the outer atmosphere of a star. To truly appreciate the sun's current stability, we must look back to its violent inception. 4.5 billion years ago, the sun was not the calm provider we know today. It was a chaotic, restless infant, surrounded by a swirling disk of gas and dust. In those early eons, the young sun was a volatile beast, throwing out powerful jets of plasma that blasted the surrounding space. It was a time of cosmic construction, where the intense heat of the sun determined the chemistry of the entire system, deciding which materials could solidify near the center to form rocky planets like Earth, and which were pushed to the outer reaches to build the gas giants. Without the sun's initial aggression, the solar system would not have its current order. It was this violent birth that cleared the solar nebula and paved the way for the stable, life-giving star that would eventually nurture us. This wasn't just a beginning, it was the ultimate act of creation, establishing the rules that every planet, including our own, would follow for billions of years to come. To solve these mysteries, humanity is pushing its limits. The Parker Solar Probe, the fastest object ever built, is skimming just 6.1 million kilometers from the surface, effectively touching the sun and enduring heat that would vaporize any other machine. It is a feat of engineering that defines the 21st century. And in 2026, the IMAP mission is mapping the heliosphere, the massive bubble that protects us from the harsh radiation of the galaxy. We are finally decoding the sun's language, learning to predict the invisible storms that could one day threaten our technological civilization. The energy the sun releases is incomprehensible. Every second, it radiates more energy than humanity will consume in 650,000 years. Even the tiny fraction that hits Earth, just 1/2200 millionth of its total output, could power the entire world for a year with just 1 hour of sunlight. Yet, every great flame must eventually flicker out. Born 4.6 billion years ago, the sun has about 5 billion years left. When it runs out of hydrogen, it will swell into a red giant, 256 times its current size. Mercury and Venus will be consumed, and according to the latest simulations, Earth too will be dragged into the solar atmosphere and vaporized. It is a tragic, inevitable destiny for the cradle of our civilization, but it is also the natural cycle of the universe. In its final act, the sun will shed its outer layers, leaving behind a dense, Earth-sized white dwarf that will quietly cool for trillions of years. The once mighty furnace will become a dim ember, a tombstone in the galaxy. The sun is not just a ball of fire, it is an intricate, dynamic physical system that breathes, changes, and defines our very existence. To truly know the sun is to realize the miraculous, fragile balance upon which our entire world stands. We are the witnesses of this star's long, magnificent life, a speck of dust, warmed by a giant, dreaming of the stars. This journey has been brought to you by inertia on the Voyage. If you enjoyed this cosmic voyage, please make sure to subscribe and hit that like button. Thank you for watching. In the deepest shadows of our cosmic neighborhood, a lone wanderer orbits closer to the sun than any other. It is small, cratered, and scarred by time. To the casual observer, it looks like a dead twin of our moon. But beneath that dusty, barren exterior, Mercury hides a secret so violent and so bizarre that it defies everything we know about how planets are born. Meet Mercury, the smallest planet in our solar system, and undeniably the fastest. It races around the Sun at a breakneck speed, completing a full year in just 88 days. Yet, it spins so lazily on its axis that a single day on Mercury lasts for 176 Earth days. It is a world of extremes, where temperatures swing from a scorching 430 degrees Celsius in the sunlight to a freezing -170 in the dark. But the real story isn't about the heat, it's about what lies beneath. Imagine a planet as a giant egg. Normally, a rocky planet has a metallic core at the center, wrapped in a thick, protective blanket of rock called the mantle. That is the standard recipe for a planet. But Mercury? Mercury has essentially lost its clothes. When scientists looked closer, they discovered that Mercury is missing over 85% of its original mantle. Instead of a thick rocky layer, Mercury is dominated by a gargantuan, iron-rich core that takes up nearly 85% of the planet's entire radius. If Earth were built like Mercury, our crust and mantle would be almost non-existent, leaving us as a giant, exposed ball of metal. Mercury isn't just a planet, it's an iron bullet, stripped to its core. Who, or what, could have ripped away so much of a planet? This is the Mercury problem, one of the greatest mysteries in planetary science. For years, the leading theory was a catastrophic collision. Scientists imagined a massive, young protoplanet slamming into Mercury with such force that it shattered the mantle and blasted the debris into deep space. Some recent, bold models even suggest a grazing blow, a collision so precise that it stripped the mantle off Mercury and dumped that material onto its neighbor, Venus. If this is true, the fates of these two planets were sealed by a single, violent moment in the chaos of the early solar system. But here is where the story hits a wall of mystery. If such a violent collision had occurred, the intense heat should have vaporized certain volatile elements. Yet, space probes have detected an abundance of these very elements on Mercury's surface. They shouldn't be there. The evidence contradicts the violence of the theory. This complexity extends to the surface itself. Mercury is a world of constant geological tension. Because it is so close to the Sun, it is subjected to immense tidal forces. These forces act like a giant hand, squeezing and stretching the planet as it orbits. This continuous stress, combined with the cooling of its massive iron core, has caused the planet to shrink. As the core contracts, the solid crust above it cannot keep up, leading to the formation of lobate scarps, massive, jagged cliffs that can reach heights of 3 kilometers and stretch for hundreds of kilometers across the landscape. These cliffs are the wrinkles of a planet that is literally tearing itself apart as it ages. The scientific challenge is compounded by the sheer difficulty of reaching the planet. To fly to Mercury is not simply a matter of pointing a rocket at it. Because Mercury is so deep within the Sun's gravitational well, a spacecraft must shed an incredible amount of orbital energy to prevent itself from being pulled into a fatal plunge toward the Sun. It requires complex gravitational assists, swinging around Earth, Venus, and Mercury multiple times, spending years in transit just to get into position. This is why, despite being our neighbor, we have only sent 2 missions to explore it in human history. Mercury is not just a relic of the past, it is a living, shrinking enigma. Even more surprising, Mercury possesses a global magnetic field, a rare trait for such a small world, proving that its deep, iron heart is still molten and churning. The answers are finally within our reach. The BP Colombo mission, a joint venture between Japan and Europe, is currently hurtling through the solar system. By 2026, it will begin its primary mission, diving into the secrets that Mercury has kept for billions of years. Mercury is the oldest piece of the solar system's puzzle. To understand why it is so naked, so small, and so iron-rich, is to understand the violent birth of our own world. We are waiting for the truth to be unraveled from the frontier of our solar system. Until then, we keep looking up. See you on the next voyage. In our night sky, Venus shines with a piercing, ethereal beauty. For generations, we called it Earth's sister planet. It is nearly our twin in size, composition, and location. But beneath those thick, swirling clouds, we find a world not of life, but of absolute, crushing chaos. Today, we peel back the atmosphere of Venus to look at the true nature of this wicked sister. Let's start with the scale. Venus is a massive world, with a radius of over 6,000 kilometers, roughly 95% the size of Earth. It is a dense, heavy planet, ranking third in our solar system in density, right behind Earth and Mercury. Just like our home, it is built in layers, a metallic core, a rocky mantle, and a thin outer crust. But that is where the similarities end. Venus is a planet of impossible motions. It spins on its axis in reverse, and it does so with agonizing slowness. One day on Venus lasts 243 Earth days, meaning the planet spins at a gentle walking pace of just 6.5 kilometers per hour. Yet, look above the surface, and the rules of physics seem to break. At the cloud tops, 70 kilometers up, a fierce, jet stream wind screams around the planet at 360 kilometers per hour. This is superrotation, a mystery that still baffles planetary scientists. Why does the atmosphere whip around the planet 60 times faster than the world beneath it? We still don't know. But the true terror lies on the surface. Because of a runaway greenhouse effect, Venus has become a pressurized oven. The temperature averages a blistering 464 degrees Celsius, hot enough to melt lead. The air pressure is equally suffocating, 92 times greater than what we feel on Earth. Standing on the surface of Venus would feel like being crushed under a kilometer of ocean water. In this extreme environment, carbon dioxide behaves as a supercritical fluid, a state where it is neither quite gas nor liquid, but a heavy, ghostly substance that smothers the entire planet. The atmospheric chemistry is just as hostile. The thick, yellowish clouds are not made of water vapor like those on Earth. They are composed primarily of concentrated sulfuric acid. It rains acid on Venus, though the heat is so intense that the droplets evaporate long before they ever touch the ground, creating a perpetual, toxic haze that blankets the world in a corrosive shroud. This chemical environment is a nightmare for engineering, which is why our attempts to explore the surface have been so incredibly difficult. In the late 1970s and 80s, the Soviet Union's Venera missions achieved the impossible by landing probes on the surface. These machines were miracles of engineering, designed to withstand the furnace, yet they survived for only minutes before being crushed and melted by the environment. They sent back the first and only images of the Venusian surface, a bleak, orange-lit expanse of basaltic rock. Those few minutes of data taught us more about the hellish reality of Venus than decades of remote observation. Even hidden beneath the thick clouds, the surface reveals a violent, alien landscape. Radar maps have uncovered massive pancake domes, volcanic formations formed by thick, viscous lava that erupted and spread outward like syrup on a griddle. Some of these domes rise up to a kilometer high, standing as monuments to a volcanic fury far grander than anything we see on Earth. Perhaps the most haunting part of the story is the past. New simulations suggest that until 700 million years ago, Venus might have been a watery world, with shallow seas and a temperate climate. But a massive burst of volcanic activity flooded the atmosphere with carbon dioxide. The greenhouse effect spiraled out of control. The oceans boiled away, and the water vapor escaped into the void of space. Venus is not just a planet, it is a warning. It shows us what can happen when a planet's delicate balance is broken. As we send new missions to pierce those clouds, we aren't just exploring a neighbor, we are studying the ultimate fate of a world that lost its way. Venus is a puzzle of heat, pressure, and lost history. To understand this wicked sister is to understand why our own Earth remains a garden in the vast, cold darkness of space. Thank you for joining me on this descent into the inferno. Stay curious, and I'll see you on the next voyage. And then, there's us, Earth, a fragile blue marble, perfectly positioned in the cosmic lottery. It is not just a planet, it is an anomaly of balance where everything, from the chemical composition of the atmosphere to the pulse of the tides, conspires to sustain the precious flame of life. But what truly makes Earth special is not just where it sits, but how it functions as a living, breathing machine. Earth is a rare jewel of geological activity. Unlike its neighbors, our planet is defined by plate tectonics, a global conveyor belt of crustal plates that are constantly shifting, colliding, and subducting. This is not just random movement, it is a vital thermostat. By recycling carbon between the atmosphere and the deep interior, plate tectonics acts as a long-term climate regulator. Without this process, Earth would likely have suffered the same runaway greenhouse fate as Venus or the deep freeze of Mars. It is the very engine of the Earth's mantle that keeps our surface habitable. The complexity of our world continues in the invisible shield that surrounds us. Deep within the core, the movement of molten iron and nickel generates a powerful geodynamo, creating the Earth's magnetic field. This field is our first line of defense, a colossal magnetic bubble that deflects the lethal solar wind and cosmic radiation. Without this invisible cloak, the atmosphere, the very air we breathe, would have been stripped away into space billions of years ago. It is a fundamental truth of our existence. We are protected by the fire that burns at the heart of our world. Furthermore, Earth possesses a unique chemical recipe. Our atmosphere is a delicate cocktail of nitrogen, oxygen, and trace gases, kept in a state of thermodynamic disequilibrium by the very life that calls this planet home. On Venus or Mars, the atmospheres are stagnant, composed mostly of carbon dioxide. On Earth, life itself actively consumes and produces gases, turning the planet's atmosphere into a self-regulating system. This is what we call the biosphere, a complex, interconnected web where the oceans, the land, and the air constantly exchange materials to favor the survival of living organisms. Consider the Moon, our constant companion. Its gravity is not just responsible for the tides that stir our oceans, it stabilizes the Earth's axial tilt at roughly 23.5 degrees. This tilt provides us with the rhythm of the seasons, a predictable cycle that has driven the evolution of life for eons. Without the stabilizing presence of our large moon, the Earth's tilt would wobble chaotically, leading to wild and extreme climate shifts that would make the development of complex life nearly impossible. We are not merely inhabitants of this planet, we are the result of a precise, multi-billion-year process of cosmic and terrestrial refinement. Earth is the only place in the known universe where the environment and the inhabitants have evolved in a synchronized dance of chemical and physical adaptation. Every breath we take is a testament to the miraculous, fragile balance upon which our entire world stands. We are but a tiny speck in this vast, swirling machinery of the solar system, but we are the speck that looks up, wonders, and calculates. We are the consciousness of the planet, the ones who have finally begun to understand the complexity of our own cradle. This journey has been brought to you by Inertia on the Voyage. If you enjoyed this cosmic exploration, please make sure to subscribe and hit that like button. Thank you for watching. Mars, the rust-colored frontier in the dark expanse of our night sky. One world has ignited human imagination more than any other. It glows with a haunting, powerful, crimson hue, a world named after the god of war. Today, we step onto the mysterious, rust-colored surface of Mars. Why is Mars so red? The answer lies beneath our feet. The Martian soil is rich in iron oxide, essentially, rust. This layer of oxidized iron covers the entire planet, catching the sunlight and casting a deep, rusty glow that has fascinated observers for millennia. It is, quite literally, a planet turned to rust. But don't let the beauty fool you. Mars is a world of extreme, unforgiving conditions. It is roughly half the size of Earth, with gravity only 1/3 as strong. You would feel incredibly light, bouncing across the dusty plains, but you wouldn't be able to take a single breath. The atmosphere is mostly carbon dioxide and incredibly thin, less than 1% of Earth's pressure. Without a thick protective shield, the surface is constantly bathed in harsh, invisible solar radiation. Yet, this small world hosts features that make Earth's tallest mountains look like hills. Behold Olympus Mons, a volcanic giant standing 25 kilometers high, nearly 3 times the height of Everest. Stretching across the surface is the Valles Marineris, a canyon system that runs for 4,000 kilometers and drops 7 kilometers deep. These are the scars of a violent and majestic history. But Mars wasn't always this desolate wasteland. Extensive robotic exploration has uncovered undeniable proof that water once flowed here, winding rivers, ancient lakes, and perhaps even vast, deep oceans. Where there was water, there may have been life. Today, that water remains locked away as ice in the polar caps and deep beneath the surface, waiting for future explorers to tap into its potential. Right now, a fleet of rovers is scouring the surface, and ingenious drones are cutting through the thin Martian air, hunting for the ghosts of ancient microbes. The day humanity takes its first step onto this red dust is no longer a dream, it is a goal. Across the millions of kilometers of darkness, Mars sits quietly, waiting for us to uncover its greatest secrets. What will we find when we finally arrive? The answer is out there, etched into the red rock, waiting for the first footprints of a new species to arrive. We are not just watching from afar anymore, we are on our way. Thank you for joining me on this journey to the red planet. See you on the next voyage. Jupiter, a behemoth that holds 2/3 of all planetary mass in our solar system. It is the elder statesman of our neighborhood, emerging from the dust of the newborn sun less than 1,000,000 years after its birth. But recent science reveals that Jupiter is not a static giant, it is a traveler, a wanderer that has defined the very architecture of our system. We now have the Grand Tack hypothesis. It suggests that Jupiter once plunged deep into the inner solar system, nearing the orbit of Mars, before being pulled back by the gravitational resonance with Saturn. This violent journey explains why Mars is so small and why the asteroid belt is such a chaotic mix of materials. Even more startling is its chemical fingerprint. The rare gases in its atmosphere suggest that Jupiter was actually born in the deep, frozen darkness beyond Neptune, drifting hundreds of billions of kilometers to claim its current throne. It is a king of the void that journeyed across the system to become our protector. Jupiter is not just a planet, it is a mini-solar system. As of 2026, it commands a core of 115 moons. Chief among them are the Galilean satellites, 4 worlds of staggering diversity. There is Io, a volcanic hellscape churning with the most intense tidal heating in the system, where sulfurous plumes erupt hundreds of kilometers into space. Europa, hiding a vast, dark, salty ocean beneath an icy shell, whispering the promise of hidden alien life in its deep, protected waters. Ganymede, the largest moon of all, even larger than the planet Mercury, is a unique world sporting its own internally generated magnetic shield. And Callisto, a quiet, crater-scarred fossil holding the pristine memories of the solar system's violent infancy. Look at Jupiter's surface, and you see art carved by immense jet streams exceeding 150 meters per second. The Great Red Spot, a massive, anticyclonic storm that has been raging for over 300 years, is so immense it could swallow the entire Earth whole. It reaches hundreds of kilometers deep into the atmosphere, its swirling colors burned into existence by the relentless touch of solar radiation acting upon phosphorus and sulfur compounds. But beneath the clouds lies the true engine of the giant. Deep inside, hydrogen is crushed under such extreme pressure, millions of times that of Earth's atmosphere, that it turns into liquid metallic hydrogen. This ocean of conducting liquid metal generates a magnetic field 20,000 times stronger than Earth's. This magnetosphere dominates the space around it, trapping charged particles and creating radiation belts so intense that they would be lethal to any human explorer, shielding the inner planets from the fury of the sun and the dangers of interstellar radiation. Jupiter's influence extends far beyond its orbit. Its massive gravitational dance may have even ejected a long-lost fifth giant planet from the solar system in the distant past, and it has acted as a gravitational gatekeeper, scattering the water-rich asteroids from the outer reaches that eventually seeded life-giving elements onto the young Earth. Without Jupiter's presence, the inner solar system would be a vastly different, and likely much more dangerous, place. The study of Jupiter is also a study of planetary formation. The Juno mission has provided us with unprecedented data, showing that Jupiter's interior is not the uniform sphere we once imagined, but a complex, fuzzy core where heavy elements are mixed deep within the hydrogen layers. This challenges our entire understanding of how gas giants originate and evolve. To know Jupiter is to understand the violent, beautiful, and chaotic past of our home. As we prepare to send new explorers to its swirling clouds and moons in the 2030s, the king of our solar system prepares to reveal its final secrets. We are not just looking at a planet, we are looking at the architect of our own existence. Jupiter remains a silent observer, a sentinel of time, and the true master of the celestial dance. Thank you for joining me on this journey to the giant. Stay curious, and I'll see you on the next voyage. Saturn, the jewel of destruction and rebirth. Saturn, the crown jewel of our solar system. At a glance, it is a vision of celestial elegance. But do not be fooled by its beauty. This is a world of gas and ice so lightweight that, if you could find a bathtub large enough, the entire planet would float. Floating 1.4 billion kilometers from the Sun, in a frozen realm of -180 degrees, Saturn is not a static object, it is a stage for a violent, ongoing cosmic drama. Saturn is a planet in a hurry. It spins on its axis in just 10.5 hours. This reckless speed forces the planet to bulge at the equator, giving it a flattened, rugby ball shape, the most distorted planet in our system. And staring down from its north pole is an enigma that has haunted scientists for decades, a permanent, massive cloud pattern shaped like a perfect hexagon, spinning in the darkness. But the most breathtaking feature of Saturn, its rings, is also its most tragic. We once thought they were eternal. We were wrong. Recent data reveals the ring rain. Billions of ice particles are being pulled by gravity and magnetic fields, falling into the planet in a steady, relentless stream. In a cosmic blink of an eye, just 100 million years from now, those iconic rings will be gone. We are living in a rare, fleeting moment of history, witnessing a masterpiece that is already fading away. Saturn has now claimed the throne as the king of moons, with over 290 worlds orbiting its sphere. But this abundance is not a sign of peace. It is the aftermath of a massacre. About 100 million years ago, a catastrophic collision of moons shattered the system, scattering debris that eventually formed those very rings we admire today. Even Titan, the largest moon, was born from this chaos, the result of two massive icy bodies slamming together and fusing into one. With its thick nitrogen atmosphere and vast lakes of liquid methane, Titan is a mirror image of a pre-life Earth. In 2034, the Dragonfly drone will descend into the alien haze, flying through the skies of a moon to uncover the secrets of its violent birth. Saturn is not a silent jewel. It is a living laboratory of destruction and creation. From its vanishing rings to the moons born from fire and ice, Saturn teaches us that the evolution of a planet is neither gentle nor permanent. It is a violent, beautiful, and breathtaking mystery. We are lucky to be watching. Thank you for joining me on this voyage to the jewel of the abyss. See you on the next journey. "60 times the volume of Earth, yet wrapped in a serene, pale blue veil. This is Uranus, the ice giant of our solar system. While its exterior suggests a tranquil, frozen world, the reality is a realm of extreme, violent mysteries. Discovered in 1781 by William Herschel, it was the first planet ever found using a telescope, fundamentally shattering our understanding of the solar system's ancient, established boundaries. Named after the ancient god of the sky, Uranus remains one of the most enigmatic, untouchable frontiers in modern astronomy. The most striking anomaly of Uranus is its orientation. While other planets spin nearly upright, like tops on a table, Uranus rotates on its side, with an axial tilt of approximately 98 degrees. It literally rolls through its orbit. This extreme tilt results in bizarre, legendary seasonal patterns, where each pole experiences 42 years of continuous, blinding sunlight followed by 42 years of complete, freezing, absolute darkness. Why is it so distorted? Why would a world be thrown so violently out of alignment? Modern simulations point to a cataclysmic event 4 billion years ago. A massive protoplanet, twice the mass of Earth, likely struck the young Uranus with a glancing, high-energy blow. This collision was not a gentle nudge, it was a cosmic hammer that knocked the planet onto its side and fundamentally altered its internal structure, leaving scars that remain hidden deep within its core to this very day. The interior of Uranus is a landscape of super-pressurized extremes. Composed of water, ammonia, and methane, the mantle exists under millions of atmospheres of pressure. In these depths, scientific models suggest the presence of metallic water and superionic water, a state where molecules dissociate, allowing electricity to flow like a liquid metal. Even more fascinating is the possibility of diamond rain. Under these crushing pressures, methane is stripped of its hydrogen, leaving carbon to crystallize into solid diamonds, which then fall like hail toward the planet's heart. This high-pressure environment is the hidden engine behind the planet's uniquely asymmetric and distorted magnetic field. Despite this internal dynamism, Uranus is paradoxically cold. It records the lowest temperatures in the solar system, reaching -224 degrees Celsius. While Neptune radiates significant internal heat, Uranus remains strangely, hauntingly stagnant. Scientists suspect that the ancient collision shattered the internal layers, creating an insulating, chaotic barrier that prevents the core's heat from escaping to the surface. It is a planet that is internally disrupted and externally frozen, a world locked in its own cold struggle. The system around Uranus is equally historic. Unlike the bright, icy, golden rings of Saturn, Uranus's rings are composed of dark, ancient organic material, as black as coal. Among its 29 known moons, Miranda stands out as a geological nightmare. Covered in 20-kilometer deep canyons and jagged cliffs, it appears as though it was once shattered by a massive impact and then haphazardly reassembled by gravity, a testament to the violent, unforgiving history of this outer region. Humanity has only glimpsed this world up close once, the 1986 flyby of Voyage 2. Traveling at 70,000 kilometers per hour, it captured data in a brief window of time, providing our only detailed look at the planet's unique features. It was a heroic, fleeting achievement. However, with 2020's technology like the James Webb Space Telescope, we have finally begun to see the active storms and faint ring structures in high definition. Uranus is not a sleeping world, it is a dynamic, evolving, and still surprising environment. Recent science suggests that ice giants like Uranus may actually be the most common type of planet in the entire Milky Way galaxy. By understanding Uranus, we aren't just studying our own backyard, we are learning the blueprint for how the majority of planets in the cosmos are formed, how they evolve, and how they eventually die. Currently, the global scientific community is moving toward the launch of the Uranus Orbiter and Probe mission in the 2030s. This mission aims to spend years scanning the planet's gravity, magnetic field, and atmospheric composition. Uranus acts as a time capsule, preserving the chaotic, formative history of the early solar system. When we finally unlock its secrets, we will hold the key to understanding the origins of our own home and the ultimate destiny of countless exoplanets across the universe. Exploring Uranus is not just a scientific mission, it is humanity's most daring, necessary journey into the unknown. We are ready to return, to listen to the whispers of this frozen giant, and to finally understand our place among the stars. nearly 4.5 billion kilometers from the Sun, where light itself takes over 4 hours to arrive, lies a world of absolute, frozen majesty. This is Neptune, the eighth and final giant of our solar system. Named for the Roman god of the sea, its piercing, vivid azure hue masks a reality that is far from tranquil. It is a world of crushing pressures, supersonic storms, and mysteries that challenge the very foundations of planetary physics. The story of Neptune's discovery is a testament to the power of human intellect. In the 19th century, astronomers noticed that the orbit of Uranus was being tugged by an invisible force. Rather than guessing, mathematicians like Urbain Le Verrier turned to the cold, hard logic of numbers. By calculating the gravitational influence of a distant, unseen body, they pinpointed exactly where this mystery planet should be. In 1846, when astronomers aimed their telescopes at the predicted coordinates, they found the blue giant waiting. It was a triumph of the human mind, a planet discovered not by sight, but by the relentless precision of mathematics, a moment where pen and paper truly expanded the boundaries of our universe. However, behind its serene appearance lies the most violent weather in the solar system. Neptune is a furnace of chaotic motion, with winds that scream across the surface at over 2,100 kilometers per hour, faster than the speed of sound. This is a profound mystery. Neptune receives only 1/900th of the sunlight that Earth does, yet it hosts the most powerful storms we have ever observed. The secret, scientists now realize, lies in the planet's internal abyss. Neptune radiates more than twice the energy it receives from the Sun, tapping into a hidden, perpetual reservoir of heat from its own core. For decades, we classified Neptune as an ice giant, assuming it was a cold mixture of water and ammonia, but recent simulations are forcing a rewrite of the textbooks. It may actually be a rock giant, with a massive interior composed largely of silicate minerals. Deep within, under millions of atmospheres of pressure, the planet defies the laws of chemistry as we know them. Water molecules are crushed into superionic ice, a bizarre state where oxygen atoms form a rigid lattice while hydrogen nuclei drift freely like a liquid, creating a complex, swirling interior that generates a strange, tilted magnetic field. This environment is also the forge for a celestial treasure. Methane gas, trapped in the deep mantle, is torn apart by extreme heat and pressure. The liberated carbon atoms crystallize into solid diamonds. These precious stones then rain down through thousands of kilometers of liquid, falling toward the core like glittering hail. It is believed that the kinetic energy released by this diamond rain falling through the interior is the very fuel that drives Neptune's ferocious atmospheric storms. This internal cycle makes Neptune fundamentally different from its neighbor, Uranus. While Uranus appears to have been chilled by an ancient, cataclysmic collision, leaving it dormant, Neptune is vibrantly alive. Its magnetic field is wildly distorted and offset from the planet's center, generating irregular auroras that dance across the sky like ghostly specters. The neighborhood around Neptune is equally alien. The ring system contains mysterious, dense clumps known as ring arcs, isolated pockets of debris that defy the usual orbital rules. Then there is Triton, the largest moon, which reveals the planet's dark appetite. Triton orbits in retrograde, moving in the opposite direction of Neptune's rotation. This is a smoking gun. Triton was once a rogue world, a Kuiper belt object captured by Neptune's immense gravity. Today, nitrogen geysers erupt from its frozen, -235-degree surface, and as the moon drifts closer to the planet, it is being inexorably shredded by tidal forces. In the distant future, Triton will cross the Roche limit, breaking apart to form a massive ring system that will make Saturn's look like a faint whisper. Humanity has only visited this blue sentinel once, during the Voyager 2 flyby in 1989. Since then, we have watched from afar as the James Webb Space Telescope reveals the planet's hidden dynamics in stunning detail. Neptune is not just a destination, it is the ultimate laboratory for planetary science. Today, Neptune has become our most important guide. As we discover thousands of exoplanets in the galaxy, we find that worlds similar to Neptune, mid-sized giants, are the most common type of planet in the universe. By decoding the deep secrets of this blue abyss, we are not just learning about our own system, we are learning the blueprint for how the majority of worlds in the cosmos are built, how they evolve, and whether they might harbor the conditions necessary for life. Neptune stands as the sentinel of our solar system, a reminder that the most profound secrets often lie in the deepest, coldest, and most distant shadows. Thank you for joining me on this descent into the sovereign of the abyss. Stay curious, and I will see you on the next, and final, voyage. Silent deep ballet. In the deepest, coldest, and most lonely shadows of our solar system, where the sun is nothing more than a brilliant, distant pinprick, lies a world that has challenged our very definition of reality. This is Pluto. For generations, we dismissed it as a frozen, dead corpse, a relic of ice lost in the eternal dark. But today, thanks to the data from the New Horizons mission, we know the truth. Pluto is not a dead world. It is a vibrant, breathing, and wildly active planet that pulses with a geological heartbeat. Discovered in 1930 by Clyde Tombaugh, Pluto was named after the Roman god of the underworld, a name that, ironically, fits perfectly for a world hidden in the dark. It reigned as our beloved ninth planet for 76 years, until the controversial events of 2006 saw it demoted. That decision caused a global uproar, a battle over words that lasted for years. But the planet itself remained indifferent. In 2015, when the New Horizons probe swept past the planet at over 50,000 kilometers per hour, it saw what no human eye had ever seen, a surface that looked like it had been sculpted just yesterday. It was not a barren, cratered rock, but a realm of astonishing, unpredictable fury. The first great mystery is the heart of Pluto, known as Sputnik Planitia. This isn't just a pattern of ice, it is a vast, convective engine. Beneath this bright, smooth plain, nitrogen ice is constantly churning, rising from the deep interior as it is warmed, then sinking back down. This is planetary respiration. It is a world that literally breathes. Even more radical is the recent evidence of cryovolcanism. Huge, icy volcanoes are scattered across the landscape, but they don't spew fire. They erupt with ice magma, a thick, slushy mixture of water, ammonia, and methane. These eruptions have coated the surface for millions of years, proving that Pluto's internal engine is still, even now, remarkably strong. But what fuels this heart? The answer lies beneath the surface. Scientists are now convinced that Pluto harbors a deep, subsurface ocean. And this is no ordinary water, it is a dense, super salty brine, thick with chemicals that could potentially support exotic forms of chemistry. To keep this ocean from freezing in the deep dark, Pluto relies on a gas hydrate insulation layer, a physical marvel that acts like a planetary-scale thermos, trapping the heat of the core and refusing to let it leak into the vacuum of space. It is a world fighting to stay warm. Pluto's family life is just as chaotic. Its largest moon, Charon, is so big compared to Pluto that they dance in a double-tilted orbit, forever locked in a face-to-face gaze. New theories suggest a kiss and capture origin, where these two worlds didn't smash together, but gently glided into each other's gravity, merging like a cosmic snowman before separating into the dance they maintain today. The four smaller moons, Styx, Nix, Kerberos, and Hydra, are caught in this gravity, spinning at frantic, unpredictable speeds, acting like chaotic tumbleweeds in the wake of the giants. It is a system in constant, beautiful turmoil. Beyond Pluto lies the Kuiper Belt, a vast, ring-shaped graveyard of icy debris left over from the formation of the solar system. Pluto is the king of this graveyard. It is not alone, it is a gateway to thousands of other worlds, each telling a story of how our system began. The existence of these worlds tells us that our solar system is much larger, much more populated, and much more violent than we ever dared to imagine. We have only just begun to scratch the surface of the Kuiper Belt. The debate over Pluto's status is not just semantics, it is a battle for our own curiosity. NASA's top leadership has publicly called for Pluto to be reinstated as a planet,
arguing that the current definition ignores the incredible complexity of this world. Pluto is not just a rock, it has a blue, hazy atmosphere that glimmers when backlit by the sun, a complex geological life cycle, and an active interior. By any metric of planetary science, it is a world that commands respect. As we look toward the future, the scientific community is already planning the next return, a new mission, one that would orbit Pluto and map the depths of its hidden ocean, is becoming a top priority. We are not just going back to see a dwarf planet, we are going back to unlock the secrets of the dark frontier. Pluto is the ultimate time capsule. It preserves the chaotic, raw ingredients of our own origin. Whether we call it a planet or a world beyond, Pluto remains a sentinel in the dark. It is a reminder that in the deepest shadows of the universe, there is always more to discover, more to feel, and more to understand. As New Horizons pushes further into the interstellar dark, we keep our eyes fixed on that lonely, pulsing heart. It is the end of the solar system as we once knew it, but for our quest for knowledge, it is only the beginning. Stay curious, and I will see you on the next, and final, voyage.
How was your journey? We have spent this time wandering through the grand, awe-inspiring vistas of our solar system. I hope you found peace in the rhythm of the stars and allowed your time to slowly melt away into a tapestry of sound and light. May your tomorrow be just as wonderful. This has been Inertia on the Voyage. Sleep well, and I will see you in your dreams.